we're asked to analyze the function by finding intercepts, listing zeros with multiplicities, whether or not we'll cross or touch the x-axis at the intercepts, determining maximum or terminal points, end behavior, and sketching the graph. Now this is similar to what your textbook has for directions, but they say to like follow a chart with several steps. These are the things that we are going to want you to be able to find. Okay, so it doesn't matter what order we do them in. Let's see, remember intercepts, at least the x-intercepts, same thing as zeros. There's also, though, a y-intercept. So let's find the y-intercept first. Usually the y-intercept is the easier of the intercepts to find. For the y-intercept, we put in 0 for x. Okay, so then now if I simplify, -1 all squared is 1, 5 squared is 25, -5 times 1 is -1/5 times 1 is -5 times 25. That's going to give us a total of -5 for the y-intercept. Okay, x-intercepts, same thing as zeros. They come from the factors that have x's with them. If you can look at it and see it's the opposite sign, great. If not, take the factor, set it equal to 0, and solve. So the first one I'm going to get is x equal a +1. And the other one I'm going to get x equal a -5. Now, multiplicities are the exponents of the factors that got you your 0. So since these are both squared, these both have a multiplicity of 2. Even multiplicity means that it's going to just touch the x-axis on the graph. Okay, so we found intercepts, zeros, multiplicities. We've done the whole cross-touch. Maximum number of turning points and end behavior. Both of those things rely, at least partially, on knowing the overall degree of this function. So the degree would be the highest power of x once you multiply the entire thing out. You don't have to multiply it all out. If you can look at it and think it's an x squared times an x squared, which would give me x to the 4th, that's fine. The other thing you can do is add your multiplicities. Either way, the degree is going to be 4. So that means the maximum number of turns is 1 less than that. 4 minus 1, which is 3. For the end behavior, we look at two things. We've already got the degree listed. The other thing, so I'm going to go ahead and copy it here, degree is 4, and the key thing is that is even. And we also look at the leading coefficient, the number in front of x to your highest power. In this case, it is -1/5, and the key there, it is negative. Even degree tells me the ends go the same direction, either both up or both down. A negative coefficient means they will go down. Okay, so now we need to tie it all together to get the sketch. So the information that I have, I've got a y-intercept at -5. I have zeros at 1 and -5. So it's a good idea to label your points. Okay, now with that, I want to tie together my end behavior. So I know that the ends are going to go down. I know that I'm only going to touch the x-axis at -5. So I know it's going to come up here and touch. Then I've got to come back and hit this value. And then I'm going to have to go in here, and I'm going to have to, again, just touch. So I'll turn and come back down. So from that, I can get a fairly reasonable idea of what this graph is going to look like. But of course, you have your calculator as well. So I've already got this put in. Looks like I forgot the negative. -1/5 x minus 1 squared times x plus 5 squared. And let's see, I need to put the square in there. Now, Let's try a standard window, zoom 6. It goes a little bit off my screen, so if I change the window just a little bit to come down to, let's say, -20 instead, now I can see a good graph. I'm going to tie that together with everything that I've found. So it comes down here. Should be a smooth graph, not pointy. It should curve. But that exhibits all of the properties that we found. That's a good enough picture. We're not looking for anything great. And notice that it does actually have the 3 turns. It doesn't have to, but this one does.